Hi, welcome to my YouTube channel Human Learning. This is the part 1 of the series of lectures that I will be conducting on machine learning, and I will start with the very basic and fundamental topic of ML called linear regression. Suppose you are a data scientist and a company approaches you with its following data. This table shows the investment of the company in its business over the years. So you can see that initially it has invested $2 million in its business, and in the very first year it has invested $3 million, and so on. Say your task as a data scientist is to predict the investment of the company in the 6th year using simple linear regression model. So how will you do that? Now, as you can see in this data, there are only two variables, years and investment. Where years is an independent variable, obviously it doesn't depend upon anything, and investment is a dependent variable. So in terms of x and y, let us represent years as x variable and investment as y variable. Now we have our x and y representation of the data, where capital X represents independent variable or the observed value, and capital Y represents the dependent variable or the actual output. Now in machine learning, the visualization of data is very important, and so we will frequently find the data plotted on a graph for better visualization. Let us plot this data on a XY graph. This is the x-axis and this is the y-axis. Let us plot the first point 0, 2 on this graph. Similarly, we will plot all other values present in the data. Now our plotting is done. Now what is simple linear regression? It is actually a basic regression analysis where we have just two variables, an independent variable and a dependent variable. Based on the changes made to the independent variable x, we predict the values of the dependent variable y. So the core idea here is to obtain a line that best fits the data as shown here. The best fit line is the one for which the total prediction error for all data points is as small as possible. Don't get confused, I'll explain in detail what is residual error and what is the total prediction error. For now, just remember this statement. This line's equation is of the form y equal to a capital X plus b, where this small y represents the predicted output. This term a represents the slope of the given line, and the term b represents the y-intercept of the line, that is, point where this line intersects the y-axis as shown here. This is the simple equation of a straight line which you must have dealt with in your high school or secondary school. Before going further, first let us understand the concept of residual and total prediction error or total error. For this, let us assume the equation of the line, which is shown here, is given by y equal to 0.9x plus 2.2. These are just arbitrarily chosen numbers, so don't get afraid that how I found these values. Okay? So say when you try to predict the value of y using this equation at x equal to 3, you get the value of small y as 0.9 into 3 plus 2.2. Just substitute the value of capital X equal to 3 in the given equation and you get the value of small y as 4.9. So this is the prediction that our model is making when I chose capital X equal to 3. Let us plot this value in the given graph. This point will lie on the straight line as shown here. But when we look at the original output, we found that the value of capital Y equal to 4 at x equal to 3. So this is the discrepancy in the prediction, or the vertical red line as shown in the graph. This is called residual at x equal to 3 and it is denoted by small e, and its formula is predicted output minus actual output, that is small y minus capital Y. So what will be the value of residual at capital X equal to 3? It will be simply e of capital X equal to 3 equals small y at capital X equal to 3 minus capital Y at capital X equal to 3. Now just substitute the value of small y as 4.9 and value of capital Y as 4 to get the value of small e as 0.9 at capital X equal to 3. Now I have calculated similarly the values of residual for all the datas and presented it in the table. Now in order to find the total error, let us represent this total error as the summation of all the residuals present in the data as shown here. Okay, so when you calculate the sum of the residuals for all the values of x, you will get the sum as 0. That is, the total error is 0. But this is insane, as error cannot be 0 for a non-zero residual. Intuitively also, we can see that unless the model makes an exact prediction, it cannot have 0 error. So this representation of error as summation of residual is an incorrect representation, as here the positive and negative residuals cancel out each other and we might get 0 error. So that's it for this video. In the next video, we will find out how to represent the total prediction error and how to minimize this error in order to get the optimum value of the parameters a and b, that is the slope and the intercept, and finally predict the close approximation of the investment in the 6th year. Remember, this was our main goal. Okay, so if you like this video, please give a thumbs up and subscribe to my channel, as this will inspire me to make more similar videos and advanced videos on machine learning. See you in the next video.